Alright, so we're going to do a quick practice problem which involves drawing 100 stereographic projections with a certain other pole that is provided to you. So now key thing to note here is the 100 standard projection that you have to draw, and then also the other pole that is given to you, which is 001, which is pointed to the north axis. Further, it also asks you to draw all the major poles that correspond to these families. And here, note that these are families of the poles. So, for example, 100 family contains 100, 010, 001, and then also the inverse of it or the negative of it. So 0 bar 1 0 and 0 0 bar 1. Not all of these might be present on this stereographic projection, but we'll see what all can we find. And similarly, you'll have some for these, some for these. Again, not all of those will be present on the stereographic projection. To answer why, because imagine this sphere and you have this equator. Your cubic crystal is sitting right in this equator, and what you're drawing is projections of planes. So for example, there is a plane that goes over here. You're drawing the projection of the plane on this equator. So this equator is sort of your projection over here. That is what you see on this, and this is what you're going to draw. So the first step, the step number one to do whenever someone asks you a question like this, so firstly draw the pole in the center. So what that means is they gave the question was to draw the 100 standard stereographic projection. So we're going to put that in the center. Now another interesting point to keep in mind here is for all the members of the 100 family, we're going to be using a box or a square notation. For the members of 110 family, we're going to be using an ellipse notation. And then lastly, let's use the blue color. For the 111 family, we're going to be using a triangle notation. This corresponds to the symmetry it has. So this has 4-fold, 2-fold, and 3-fold symmetries. But we don't have to get into the depth of these. So yeah, let's place the 100 standard stereographic projection in the center. So that will just go right here. So this is 100. And after that, the other pole that was mentioned was the 001 pole, which is pointed to the north axis. So for us, the north is right over here. So this is the north, this is the south. On the right side, we'll therefore have the east, and on the left side, we will have the west. Alright, so the north, as given in the question, becomes the 001 pole. So let's just make another square box, and that square box becomes 001 pole, and that is provided to us. Alright, now with these two poles drawn on the projection, we can think about how to fill the other east, south, west, and then we'll fill the rest. Think about how to fill the east, south, and west. Let's look at these values. So what this means is that the north axis, which is, let's say over here, is 001. Then you have an axis with the center. So the one in the center is the axis that always points out of the plane. That means if I draw this orthogonal projection, the axis pointing out of the plane would just be 100. So you can see 100 if you compare it with x, y, z or h, k, l. This basically is the x-axis. The one pointing to the north, this was the north, is the z-axis, and therefore by the cross product rule, the one pointing to the right side, which in our case is the east, will be the y-axis, and the notation for that would be 0, 1, 0. So that gives us the second point, which will be the east. So we'll draw right on the east this to be 0, 1, 0. All right. And now to draw the west and the south, we just take the opposite. So what that means is that if this is the z-axis, the one going in the opposite direction will be minus z. So the south that we have, this south pole, this becomes the opposite of the north, and by opposite we mean it to be 0, 0, 1 bar. Same thing happens to the west. That just becomes opposite to the east. So that will just become 0 bar 1, 0. Alright? So just the opposite to the east. And with these drawn, we have completed all the poles that belong to the family of 100, all the major poles that belong to this family. And now what we can do is use some form of intersection to draw the rest of the poles. So let's move on to the second family, which is the 110 family. The way you can draw that is think about intersections. So how would you make, if you have something like, so we have 110, we have 110. If I take the center point, which is 0, 100, and then add the east, which is 0, 1, 0, think about these as vector sum. This will simply be 1 on the x, 1 on the y, and then 0 on the z. So this is how you can get the 0, 1, 1, 0. And this vector sum is simply a bisection. So what that means is we take this center to the east axis and we'll do a bisection of this. Now on this projection, each of these strong lines of this, the next one, these correspond to 10 degree of change. And the smaller grid values, which is, for example, all these tiny grids, they are 2 degrees each. And then the entire thing over here is 10 degrees. And same with this. So this entire thing is also 10 degrees. And same with the next one. This is 10 degrees. So what you can actually even see is we can count the degrees. So this would be 10, 20, 30, 40, 50, 60, 70, 80, 90. So you can see the angle between these two poles is 90 degrees. So when we want to do a bisection, we'll just do 45 degrees. So we'll count 10, 20, 30, 40, and then 42, 44, and then here is where we'll have 46. So let's draw our green ellipse, which now is at 45 degrees from both 100 and 010. It is the sum of these two, so that sum simply becomes 110. Right? And we can do the same thing on the opposite side of this. So we count 45 degrees, so 10, 20, 30, 40, 42, 44, and then 45. So we draw an ellipse over here, and this will be the sum of the west and the center, which just becomes 1, bar 1, and 0. And you can do the same thing on the center great circle. So keep in mind, we're doing all these at the great circle. So the center circle, or it looks like a line, but it is a circle because it's on the sphere. This itself is the entire diameter, and this is the great circle. These lines over here, these are the great circles that connect the north to the south, because they look like an arc, but they are circles because they complete on the other side of this projection. And then the outermost circle joins all the north, south, east, west. This is also another great circle. So these bisections that we're doing can only happen at great circle. The reason being that these angle counting that we're doing, the 10, 20, 30, 40, 42, 44, 45, that only happens along a great circle. So let's take another example. So now let's fix the center in the north. So we can count 45 degrees from either side. So let's count it from the north side now. So this will be 10, 20, 30, 40, 42, 44, and then 45, somewhere right here. And then this will be the sum of the center in the north. So that will be 1, 0, 1. And then same thing on the center in the south. Here we need to have 10, 20, 30, 40, 42, 44, and then 45. Sum of the center and the south. This will just give us 1, 0, and bar 1. So now we have filled some of the poles which correspond to these regions. And as I said, we can do the same thing on the outermost circle because this is a great circle. So let's try to do that between north and east. So count 10, 20, 30, 40, 42, 44, and then 45. And this will just be the intersection of north and east. So it will be a sum of that. So 0, 1, 1. And then same on the left hand side from the west and the north. 10, 20, 30, 40, 42, 44, 45. And then this pole is just the sum of the west and the north. So this becomes 0, bar 1, 1. And then on this side 10, 20, 30, 40, 42, 44, 45. This becomes the sum of west and the south. And this will be 0, 1, bar 1, bar 1. And the last one being the east and the south. 10, 20, 30, 40, 42, 44, 45. And then this sum of east and south becomes 0, 1, bar 1. So with that, we filled up 8 different poles that correspond to the 1, 1, 0 family. So now we are done with this family as well. And the last one that we have is the 1, 1, 1 family. Now the 1, 1, 1 family can get a little tricky, but we have a few simple approximations that can help us with these. So the first thing that you would want to do is basically join the 0, bar 1 to the center and the other cross point. Another thing that you'll notice is this end is the exact opposite of the other. So if this is 0, bar 1, that is just a negative multiplied to it. So this is just 0, 1, 1. And same with over here, 0, bar 1, 1. You multiply a negative 1 to it and you get 0, 1, bar 1. So we'll join these 2 points passing through the center. We'll join these 2 points passing through the center. And then let's see what we can do after that. So I would highly recommend on your exam sheets or on your notebook to use a ruler to do this. I am just gonna run a freehand approximation just for demonstration, and same on the other side. Sort of a poorish freehand approximation, but you can see these two should be absolutely straight lines passing through the center. Now the thinking about the 1, 1, 1 plane, similar to what we did earlier, now we could do the same thing. So instead of, so let's just still pick the center up, 1, 0, 0. If with the center, so this is the center, if with the center we add 0, 1, 1, you can see that we can obtain 1, 1, 1. So let's see where is the 0, 1, 1. So you'll notice that here is my 0, 1, 1. This is the center. Alright, so we got to do an intersection of the center with the 0, 1, 1. Now, as I was saying, to do the intersection and counting 45 degrees, you can only do if both the points are on a great circle. Now, these 2 points are not on the same great circle at the moment. So you could have another stereographic projection, rotate it, and find the exact 45 degree point. Here's a quick trick. So we counted the 45 degrees from 1, 0, 0, which was the center, to 1, 1, 0. Now, the interesting thing with these projections is that any point on this entire great circle will be at 45 degrees from the center. So you see how I'm drawing this great circle, which goes all the way from north to the south. And on exam sheets, I'd recommend using a pencil in case if you erase things and if you make mistakes. Now, any point on this entire great circle, so even the point, let's say over here, so if you pick up this point on this great circle, it is exactly at 45 degrees from the center. So with that information, what we can do is, I'm going to complete this further. What we can do is we can find the intersection of the line which connected the edge and the center, and then take a point which is on the great circle and intersects that line. So which means that I'm talking about this over here, and this intersection will become the sum of these two, or the bisection of these two. So what that becomes is, that becomes 1 1 1. And similarly, on the other half of this circle, the intersection of this great circle that we drew, which was at 45 degrees. Again, why was it at 45 degrees? Because we went 10, 20, 30, 40, 42, 44, 45 to find this 100. Now the intersection of this great circle with the line that connects the center of 100 to the outside pole of 101 bar 1, that intersection now becomes my new bisection, which will be the sum of center and this pole. So that sum is simply 1 bar 1, oh sorry, 1 1 and bar 1. So just sum of these two. And then you can do that same extension on this side, where you extend the great circle that corresponds to the 10 bar 1 on both the sides of your wolf net, and then that will, this is 1 bar 1 0, we find the intersection. So the intersection happens right over here, we mark that, and then that just becomes the bisection of 0 bar 1 bar 1 and 1 0 0. So it's just the vector summation. So this will be 1 bar 1 1, and then the last one, which is just above the center line, will be the intersection. And keep in mind, again, the point here is that any point on this entire great circle is at 45 degrees from 100. So here this intersection of the great circle and the line will just be the vector sum of this center point and the outside point, and that comes out to be 1 bar 1 1, right? And with that, we have drawn all the all the major poles and the entire stereographic projection that was requested in the question. And how did we begin? We first drew the center point, which was the requested standard stereographic projection. Then we marked the other pole that is provided to us. In this case, it was north axis. It could be the south axis. It could be the east axis. You could be given any axis. So you have to then mark that, then figure out the remainder of the axes, and we did that, and then we filled up all the outside, then the twofold poles, which was the intersection, this green colored, and then we picked the last one, which was a threefold, which is the bluish color. And I can post the entire result, but yeah, this becomes your stereographic projection. So try to do this again by yourself, and you'll notice that for making this, you do not need an extra stereographic projection. So if in the exam, if someone just gives you the wolf net printed out, so if someone just has a better version of the wolf net like this, you don't need to do any tracing or anything. You can just draw the way we just drew in this example. And I'll add another example for you to practice, but this is sort of a first version where you can learn how to draw it, and then I'll add another example and you can follow along and maybe test your learning.